Hey, pre-calculus students, today we're going to talk about parabolas. So let's first just talk about what is a parabola. You probably remember parabolas from algebra. They're kind of that U-shaped thing. Well, where do those points come from besides an equation like an x squared? We usually think as a parabola as an x squared equation. Well, it's actually the set of all points in a plane equidistant from a fixed point called the focus and a fixed line called the directrix. Now on your screen you can see a point and a line, and as they get closer together the parabola is closing. So every point on this red parabola is equidistant from the blue dot and the blue line, and we'll look more closely at that in a moment. Okay. So a parabola, there are four forms of this equation. Now I'm going to split it into 2 and 2. So the first two, and this again goes on page 21 of your interactive notebook. This is parabolas, and these are your four parent equations. I like to call them skeletons because they're empty. They're just the bones, no meat on the bones. It's just the skeleton equation. So the first one, and the form that it's in, is x minus h quantity squared equals 4p times the quantity y minus k. So this one is where x is squared and p is positive. So this 4p portion is positive. This is an up-facing parabola, and we learn those in algebra. The second form is also an x squared, but it's x minus h quantity squared is equal to negative 4p times the quantity y minus k. So again, we have our x squared, but p is negative this time, therefore this one faces down. And again, that should be pretty easy. Now the h and the k portion, I hope you recognize those. hk is your vertex. Because remember, a parabola has a vertex that we count up, left and right, or down, left and right, depending on which way it's facing. Now let's look at the other two forms. Okay, this one exchanges the squared term. So this one is the quantity y minus k quantity squared. Now notice the k goes with the y, even though it's first, is equal to 4p x minus h. And again, the vertex is hk. And one of the things you got to remember is the h goes with the x and the y goes with the k when you identify that vertex. This one's a y squared, and the p, the 4p part, is positive, so it opens to the right. And then the final form is the quantity y minus k squared is equal to negative 4p x minus h. A y is squared, but the p is negative. So yes, indeed, it does face to the left. Okay, and those are the four basic equations for a parabola. Now, just one thing I want to mention. If you remember doing functions, if you do a vertical line test, I've drawn some vertical lines, the x squared equations pass the vertical line test, but the y squareds don't. So these last two are actually not functions, but the first two are functions. Okay, so let's practice graphing these. We're going to graph and state the vertex, the focus, and the directrix. The focus again is that point that's equidistant from the parabola, and the directrix is the line that is equidistant from the parabola, same distance from the focus. So the first thing we want to do is decide on the direction. This is an x squared, and the 4p portion is positive. Remember, 4p is on the side of the equation without the squared term. So if we have an x squared and 4p is positive, that means it's going to open up. So we can just put up. Okay, the vertex, we're just going to look for H and K. Now, if you go back to your formulas, I'm going to flip back for a second. Okay, it's X minus H. So since this is a positive 4, it's always the opposite sign. So minus 4. And the same thing with the minus K. That's just positive 1. So these are always the opposite sign of what you see in the equation. Now, to find the focus and the directrix, this is what you're going to do. You're going to start first by plotting the vertex. 1, 2, 3, negative 4, positive 1. We know that the graph is going to face up. This portion, this 4p, is very important. I'm going to set 4p equal to that positive 12. That means p is 3. Now, 3 are the units you're going to count from this vertex to find your focus and your directrix. So since this is facing up, I'm going to go up 1, 2, 3. That is my focus. I'm going to put an F there for focus. And I'm going to go down 3, 1, 2, 3. And that is the directrix, which is a line. Now, notice I am not drawing a solid line. The reason I'm not drawing a solid line, that line is not the parabola. That is a line of reference that helps create the parabola. So from here, I have my vertex, which I just got from H and K. I found my focus by counting P up. I found my directrix by counting P down. So when asked for the focus, we want to write this as a point or an ordered pair. So that's negative 4. And I went up 3 from 1, so that's positive 4. Now the directrix, I went down 3. 1, 2, 3. I'm at negative 2. Now horizontal line is always a y equals. Y equals negative 2. And that's your horizontal line. Now, how do I know how wide to make the graph? Well, this is very easy to do. What you're going to do is you're going to go to the focus. And you're going to count 2p to the left and 2p to the right. So I'm going to go to my focus and count 1, 2, 3, 4, 5, 6. 6 units away. Where am I getting 6? 2 times 3, which is 2 distances of p. And then I'm going to count 2 to the right, 2 p's to the right, 1, 2, 3, 4, 5, 6. Now, from the vertex, the parabola is going to go up through each of these points to the left and to the right. Now let's talk about that whole equidistant concept, okay? Every point on this curve is equidistant from this line and the focus. And let me just show you how. That distance is the same as that distance. The vertex is halfway in between. Okay, how about another one? Let's pick this point. So this distance from the focus to the point on the graph is equal to this distance. Those two are equal distances. Same here, this distance is the same as this perpendicular distance. Boom. So every point on this parabola is equidistant from a focus and a directrix. Now, those last few lines I drew showing you the equidistant part, those are not necessary. This is what you're going to graph when you're graphing a parabola. You're going to graph the vertex, the focus, the directrix, and then you're going to count 2p to the left and 2p to the right to draw how wide the parabola is. So here are some steps. You plot the vertex. Then you use p to count from the vertex to find the focus. Use p to count from the vertex to the directrix, and then you use 4p for the width which is 2p to the left and 2p to the right. Okay, so let's try in the second one. Okay, again, you should be putting this into your your interactive notebook. So this time we have y minus 3 squared. So we have a y squared first. That's one of our left or right facers. We're going to look at the coefficient, which is 4p to the side of its left right. Well, it's negative. That means it's going the negative direction, or it's going to the left. Okay, so which way is this one going? This is going left, which is going to face this way. Okay, our vertex. Now, you have to be careful. When your y squared is first, a lot of students say, oh, it's 3, negative 4, but it's not. You've got to look at h and k. H is always with x, so it's negative 4. K is always with the y, which is positive 3. Always the opposite signs. So again, let's plot our vertex first. 1, 2, 3, 4, 1, 2, 3. So that is our vertex, and I'm going to call it B just to make it easy. Okay, now we know we're going to go to the left and to the right this time instead of going up and down. We're going to go left and right for the focus in the directrix. Well, whichever way it faces is where we count our focus. So how far do we count? Well, let's take our 4p from our equation and set it equal to negative 8. Because remember, our equation said 4p was equal to this number, so p is negative 2. Negative just means I'm going to the left. So I'm going to go to the left 2, and there's my focus. I'm going to go to the right 2, and there's my directrix. Now, the directrix this time is up and down because I have a left-right facing parabola. Okay, so what are the coordinates for the foci? Well, from here, I went back 2 more, and so that's negative 6, positive 3. And my directrix is a line. This time it's a vertical line, so it's x equals negative 2. Okay, so there's my directrix, my focus. Now I need to know how wide my graph is. Well, since p is 2, or negative 2 in this case, 2p is going to be negative 4, or 4. If you think about just distance is always positive. So you go 1, 2, 3, 4. From the focus, 1, 2, 3, 4. Always count this width from the focus. And there is the graph. There we go. So we just did a left-right facing graph. Hey, now let's look at how to change a parabola from non-standard form to standard form. So this will be page 23 in your interactive notebook. Okay, it says write the equation in standard form, state the vertex, focus, and directrix. So the first thing you want to do is look at which term is squared. So this one has a y squared. And you're going to move the c, which is our constant, to the other side, the side that has a variable that's not squared. So we're going to take this 39 and we're going to move it over to the non-squared side, which is the side that has the variable x. So that's our first step. Now what we're going to do is go to step 2. So that's done. Complete the square. So the squared side, we need to complete the square, and I sing a little song. You half it, you square it, and you add it to both sides. So you take the b term and you half 10 and square it. So I'm going to add 25 to both sides. And what does that give me? That gives me 8x squared. 8x plus 64 equals the y squared portion that I just completed the square on. So y squared minus 10y plus 25. Okay, so I've done that part, completing the square. Rewrite as a binomial squared. So the side we just complete the square on, it factors into y minus 5, y minus 5, or y minus 5 squared. So factor the right side. Now on the other side, so we've done that, we're going to factor out any coefficient. We have a coefficient of 8, so let's factor out that 8, and that leaves us with x plus 8. Okay, so now we can define our characteristics. Now we're going to look for the vertex, the focus, and the directrix. So let's look for the vertex first. The vertex is always equal to the opposite sign. So look at the x portion, that's negative 8. The y portion, opposite of that, 5. Okay, the focus, we have to look at what our coefficient is. So 4p is equal to 8. So p is a positive 2. So from our vertex, we're going to find the focus. So now I'm going to go to my graph. I'm going to plot negative 8, 1, 2, 3, 4, 5. And I know that is my vertex, so I'll call it V. My P is positive, so I'm going to go to either up or to the right, depending on which way this faces. Let's go back and look. This one is a y squared, which means it's a left-right facer. So it's going to face to the right, so my focus will be 2 to the right. So my focus is now at negative 6, 5. And then from the focus, I'm going to draw my 2 points. So I'm going to go up 2p in each direction, up and down. So up 2p, 1, 2, 3, 4. 1, 2p, another 2p, and there is my parabola. Okay, now I haven't finished because I still need to draw my directrix. And my directrix, if this focus is 2 to the right, that means my directrix is 2 to the left. So it's over here. And again, draw it as a dashed line. It's a line of reference. It's not part of the graph. It's a vertical line, so it's x equals negative 10. Okay, and that's how you find those characteristics to graph your parabola and find your clues. So I hope this was helpful on figuring that out. Now we're going to look at finding the equation of a parabola with a vertex and a focus given. I call these clue problems because you're given information and not the equation. So the first thing you want to do is graph. So I'm going to graph my vertex. My vertex is at 3, 9. My focus is at 3, 1, 2, 3, 4, 5. And let's call this F for focus and V for vertex so I don't get confused. Now, what this information gives me is the distance from the vertex to the focus, which is 4 units. So that means P is equal to 4. And since I'm looking for the equation, I actually need 4P. So multiply both sides by 4, and we get 4P is 16. Now, we can also figure out the facing. Because the vertex is above the focus, that means this one is going to face down. That means my P is not positive, but my P is actually negative. So when I go to plug it in, my 4P will be negative 16. Now, our skeleton equation for a down facer would be x minus h squared is equal to 4p times y minus k. Now, we know h and k is the vertex, and we have that. So let's plug in a 3 and a 9. So it's going to be x minus 3 squared is equal to 4p times y minus 9. Well, just a minute ago, we counted this distance p and decided it was 4, multiplied it to find 4p, and then made it negative because it faces down. So let's go back and replace 4p by a negative 16. And we have our equation. So the equation for the problem with a vertex at 3, 9 and a focus at 3, 5 is x minus 3 squared is equal to negative 16, y minus 9. Now let's look at our second clue problem. This time we're finding the equation of a parabola given its graph. And again, we need to think about the skeleton equation. So this is an up facing. So I know it's going to be an x squared. And since it's an up facing, it's also going to have a positive p. So I'm going to write the skeleton equation, x minus h. This is the squared portion is equal to 4p. And we just decided this is going to be positive times y minus k. Now we already know h and k, so let's plug in our h and k from our vertex. So I'm going to have x plus 1 quantity squared is equal to 4p times y minus k. Y minus negative 2 is plus 2. So always plug in that opposite sign. Now, we don't have the 4p, which we do need to find. And we don't know where the focus is, so that's not going to help us. But we do have a point. And what do we know about a point? The first position is an x-coordinate, and the second position is a y-coordinate. So that means I can plug in 4 for x and 6 for y into this equation, and then I'll be left with one variable. So let's plug in a 4 here, so 4 plus 1 squared is equal to, we don't know p, so bring that down. The y value is 6, so plug in 6 plus 2. And let's simplify this. So this is going to give me 5 squared or 25. Bring down my 4p, and I have 6 plus 2 is 8. Now, you're going to be tempted to multiply 4 times 8 and get 32. I'm going to tell you, please don't do that. You're going to make your life harder. We need 4p for our equation. So let's just solve for 4p. So let's divide both sides by 8. So that means 4p is equal to 25/8. And we can stop right there and just plug that in for 4p with our vertex. So let's write our final answer, okay? Our final answer would then be x plus 1, because that's our x-coordinate of our vertex, is equal to 4p, which is 25/8 y plus 2. And boom, we have the equation that we need given our clues of a vertex and a point to create the equation of the parabola. So let's look at a quick summary of what we did today. The first thing we did was write the 4 forms of the parabola equation. When we have an x squared, we have an up facer or a down facer. When we have a y squared, we have a left or right facer. We also learned how to graph a parabola from standard form and identify the vertex, the focus, and the directrix. Remember, the focus and the directrix are equidistant from the vertex. The third thing we learned how to do is how to change the equation of a parabola to standard form using CTS, which is completing the square. You have it, you square it, and you add it to both sides. And the last thing we did was learn how to write the equation of a parabola from clues. And we were given the vertex and a point, and the other one you were given a graph. So it's writing those equations given some form of a clue. So what are we going to do tonight? We're going to do worksheet 3 on parabolas.